Going over some math skills that you're going to learn this year in your Algebra 2 trig course, but you learn them later in the year. So unfortunately, we need them now though, because in the next chapter, we're going to study projectile motion. So remember how so far we've looked at objects moving either up and down or left and right? What happens if an object moves both up and down and left and right, like it moves like a parabola? Okay, so in this chapter, we're going to need to know the quadratic formula, and we're going to need to know basic trigonometry of right triangles. So I'm going to teach you that today. So it's more of a math lesson today. I know you just said math, so it's a bit of a double math for some of you. Okay, but bear with me for a little. So the quadratic formula you saw already if you watched the video for section 2.3. And I told you don't worry about it too much, but that was what I was using. It's called the quadratic formula. Let's describe what it means. So if I had a quadratic such as x squared plus 4x plus 3, and I set that equal to 0, I could easily factor that. What would that factor into? Julia?
X plus 3, and then x plus 1.
Yep. Okay? And I made it easy on purpose so you could see that, right? Very simple. 3 times 1 is 3, 3 plus 1 is 4. That's how we know how to factor. Now, what if you couldn't factor is the question then. Okay? What if you couldn't factor? And in physics, our numbers are usually decimals. When we get to quadratics, it's usually in the equation with 9.81. So you're not going to have an easy problem where you can just factor it. You're going to have constant or coefficients instead of 4 and 3, like 9.81 or 4.905 comes up a lot. Or another number as a constant at the end, but you're going to have some decimal values. So you're not going to be able to factor. Now, you can solve them two ways. You can use what I'm going to show you in a minute, which is called the quadratic formula, or that's algebraic, or you can graph them on the calculator. Okay, and you can look for the x-intercepts. And we'll talk about how to do that as well. So we'll do both of those things today. So the quadratic formula. Okay, the quadratic formula says the following. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, for those of you that have seen this before, can you explain what a, b, and c are in the formula? What are a, b, and c? I know some of you have seen it before. Dirks?
B is 4x, C is 3, and A is x squared.
Close. Very close. What mistake did he make?
It's the coefficients.
Only the coefficients.
Oh.
Okay, no x's in there, okay? So what's a really, Dirks?
Squared. Oh, 1.
1. Yeah. So 1 in front of the x squared. A is 1, b is 4, c is 3. All you need to do is plug into this formula. That's it. If you plug in the numbers, you get the roots of the equation. Okay, you get the roots of the equation, the solutions to the equation. So let's use this example as a demonstration to see that we'll end up getting, if we solve this, negative 3 and negative 1, right? Those are the solutions to this if we were to solve the quadratic. Let's apply it to this formula. So go ahead and wherever you see an A, plug in a 1. Wherever you see a B, plug in a 4. Wherever you see a C, plug in a 3. And the 1 at the bottom as well. So A is the first coefficient right here, whatever's in front of x squared. B is whatever's in front of x. And C is the constant at the end of the quadratic. So it's in that order if you go from decreasing degrees. Okay? So again, this, I'll point them out if it helps. A is 1, B is 4, and C is 3. And you could always list them if you want to on the side. Okay, but they're also obviously in the equation that you see there. So those are the values of A, B, and C in this equation. If you just plug them in, you'll get negative 3 and negative 1. Now, if you're confused about what to do here, just pause when you get to that part, we'll go over it. But start right away. Start plugging it into the formula.
I'm sorry, I may have missed it, but like for the x, which would you want us to use? X equals 3, or we need
What,
to
Jack?
just the x. We said that's what do you want us to do?
What there? I need you to stop talking.
Well, this is the factor. Okay, first off, just show us you got x equals negative 3, x equals negative 1.
That's
and
fair.
x equals- So you know what the answers are already. What I'm asking you to do is just to take this formula and plug A, B, and C into the formula.
Okay.
So there's no x involved.
Okay.
It's just the numbers, right?
Yeah.
Okay.
Thank you.
Is that what you were doing with
Yeah.
the x? Okay.
Yeah.
You did this. You asked first.
Alright, yeah. Why
Oh,
are
yeah, because he's one of those.
Because what if they have
coefficients.
See how we factor into x plus 1, x plus 3. We got the answers. What if you can factor? What if we were like decimal values? So like 2x squared plus 4.5x minus 3.7. You can get solutions to that and you can't factor.
Oh, okay. So this one you would be able to.
Yeah, I'm making it easy so when you get an answer, you can check that it's right.
Okay.
But we're going to do one in a moment where there's decimal values.
Okay.
So far so good, but we need to. You know what I mean? Square root. I thought we were turn around
Oh, so are we back? There it is.
The answer should be -3 or -1.
Okay,
There's two answers. All right, let's do this. I just wanted to give you a minute to try. All right, here we go. Let's plug in. Now, I'm gonna point out the common mistakes that I noticed already, and then common mistakes that I'm used to seeing with my math students. So first, it's negative b, and b is positive 4, so it's -4 to start. Okay, if b were negative, it would then be -4, and thus positive. Okay, next, plus or minus, the square root of b squared. Well, b is 4, so b squared is 16, minus 4 times a times c. Do that in your head, please. A is 1, c was 3, so 4 times 3 is 12, okay? All over, relax. All over 2a. All over 2a, but since a is 1, I don't really care about it, so I just put it all over 2. All right, again, this problem is working out very nicely. The square root is a perfect square because it was factorable. Whenever an equation could be factored, if you use the quadratic formula, this radicand will end up becoming a perfect square, right? Square root of 4 is just 2. So here, we've got,
You said whenever the square root is a perfect, I'm sorry.
whenever the equation was able to be factored in the beginning, you'll get a perfect square into the radical. Since we were able to factor in the beginning, that's what causes that. So far, so good? Again, 16 minus 12 is 4. The square root of 4 is 2. All right, here's where we're at. Now, at this point in time, we're pretty much done, but we need to break it into two answers, the plus or minus. So write this twice now, once with a plus and once with a minus in that location where you see the multiple arithmetic symbol, whatever the heck that really is called. So break it into two spots. X equals -4 plus 2 over 2, and x equals -4 minus 2 over 2. Okay, again, I'm taking this plus or minus and just breaking it into two parts. One of which has a plus in the middle, one of which has a minus. -4 plus 2 is -2 over 2. The first one gives me -1 as an answer.
So 2 plus or minus.
Yes.
That's one of my answers right there. Okay, the other one is -4 minus 2, which is -6 over 2, -3. And we get, lo and behold, the two answers we got from factoring. -1 and -3. Okay? Again, that was a very simple example where you could factor. You would never use the quadratic formula if you could factor. It doesn't make sense. It's more work than you need to do. So let's do an example now where we have decimals, okay, for the coefficients. So I want everybody to try this because in a minute we're going to use our graphing calculators, which you all have with you, to check that that's correct. Okay, so let's go ahead and do this. Let's pick a new example. All right, we'll come up with some values. So instead of x as a formula, now I'm going to use t as a variable. I'm going to use t just to show you that it doesn't matter what variable it is. -4.9 t squared plus 5t minus 2.7 equals 0. Okay, it's the same thing we just did, except there's a t, and now the numbers are decimals, or some of them are. Okay, negative 4.9 and the 2.7. So, plug everything into the quadratic formula to start. Okay, which, by the way, you should memorize, meaning you will need to memorize the quadratic formula. Okay. I don't think I put it on the formula sheet. It's something in math you're going to need to memorize anyway, so I make it mandatory, so when you get to this in math, Mr. Hall will be like, oh, great, you guys did it right.
So legitimate negative 4.9 by 2.
You need to plug in all of the values, A, B, and C into there, and then solve and simplify. Yes. Yeah, we were negative, so B is positive. We see this, right? Positive, A is negative. But if B is negative, negative, negative becomes positive. A, B, C, and then order always. As long as it's in the correct order. Guys, there's always A, B, C, presuming you have T squared, T, and then a constant. It's got to be in that order. Yep. And C is? Yep.
I bought this calculator, and it's kind of nice. They only had the one with the and so that part shit,
Because I yeah.
no. So I may just return it. You have that chart of that? It's charted. And it supposedly takes like 8 hours for that. And every time I try to get the orange light turns on, and all this so that's not.
I mean, if you give me a second, I can just pop this off and see what's going on here, but I don't know. It's not charged. You know what I mean? It's not charged.
Yeah. I mean, the orange light turns on, but I don't know. It may actually I don't know.
I would probably, where'd you get it? Like Staples one? I'd probably just bring it there and say, I got this a week ago or 2 weeks ago, it's not working. I don't know, I mean, if you come out later, I have some screwdrivers, I just take them out. I'm sure it's just like, I don't think so. If you're looking at it, it's probably looking at it. What? Drink? At that point, you're, I don't know. Share with your, share with, Ken now with this. So in these problems, I would recommend that you write it out because the decimals, you can't do that math in your head.
So good. Because they both say the one.
Okay, plug in like that and then go ahead and simplify using your calculator.
Or you don't have when Bob is missing. So that's it. Where'd you
Hey, simplify the radicand by itself and then take the square root. So 25
minus.
This is a triple negative, isn't it?
Yes.
Oh, we're going to get a negative answer under there.
Yeah.
Change the 2.7 to positive.
Oh, come on. You're throwing
Oh.
everyone, really?
Who would have thought? Yeah. Change that to positive. It's fine. 2.7. Change the original equation to positive 2.7.
Oh, wait, that's true.
At the end, you're orthodox for both, yeah? So I'm going to complete the radicand.
I hate that
I'm going to do the calculator on the board so you can see. Okay. Round, like the final answer I would round. Store it. You know how to do it? Come on, store it.
Okay, if you store something.
Why are you yelling?
What should I write them down?
So in your TA folder, there's a class classroom. So you can open that in Notability and spit a check.
Mr. Howell, if you store something over a different letter, is it going
It overstores automatically.
Automatic.
Automatically. It's
It's
wild.
hydromatic.
It's wild.
Oh my god. Pretty much exactly what it is. Freeze lightness.
All right, ready? Let's do this together real quick so you can all see.
Oh my god, I'm so.
Okay, so we've got under the radical, listen. We've got 5 squared. So we start with 5 squared. And you can do this all in one line, please. Minus 4 times negative 4.9 times 2.7. Oops. Notice I make use of the parentheses a lot instead of the multiplication symbol to be careful. Okay, it is easier. So this is what you get under the radical, 77.92. Then, second square root, second answer. Do we all know how to do that by now? Yes. The answer key is if you hit second and then hit the negative sign right down here. It pulls up the previous answer you got and it uses that as its value.
Oh, I just.
Okay, so if you want to take the square root of 77.92 and you don't want to type in 77.92, or maybe it's a decimal that is a non-repeating decimal that goes on forever, right? And has no pattern. Well, then we want to use that answer function. Okay? And we get the square root. So that's the number that's going to be underneath the radical there. So let's put that back over there. 8.827. Okay, I know, right? Going back and forth. This is wild. 8.827. 8.827 all over negative 9.8. Okay? Finally, the last step, what are we going to do?
Divide.
Well, what are we going to do? We have 2 answers. How do we do it? Yeah, 1 plus and 1 minus. I know, I made a typo. Hold on. Yeah, there should be a 2 there. All right. We're going to end up getting 2 different answers. Now, in the case of physics, we have to use some sort of common sense. If we're looking for time in this problem, we're going to most likely use the positive answer. But that does not mean that you use the positive sign, because watch what happens in this problem. This numerator, please look up even if you're working, this numerator turns out to be, let's see, it's going to be positive over a negative, right? This numerator is positive, the denominator is negative. So this answer is going to be a negative time. This answer is going to be a positive time. So please, don't reject this one because you think you're using a negative sign, it's going to become negative. We have 2 negatives, they cancel. So when you're doing the plus or minus part of the quadratic formula, you need to check both every single time. Okay, we have to check both every time. So let's go ahead and do that together. So we've got, and watch what I'm going to do, please. This is how you save time on SATs and tests. Please don't type this twice. So I'm going to do this. I'm going to say parentheses, -5 plus. Oh, hold on. 1 sec. We're there? There we are. -5 plus 8.827. 827, close parentheses, divided by -9.8. Okay, that gives me the first root. Now,
That's what I got.
that's not the one that we're going to use because it's a negative time. We're going to write it down still, but here, watch the next step. Don't rewrite the whole line. Press, everybody, press this. Press second, and then press the enter key. It pulls up the last entry that you put in. So it'll repeat it, and then we can just change that positive sign to a negative sign. Just scroll over and change this to a negative sign. Okay, it repeats the previous line, make that a negative right there. Okay, so put a minus there, and now hit enter. And we get both roots quickly. Okay, the one that we care about is the 1.41 right now, simply because we're looking for the positive root because it's time. I'm going to write them both down, though, and we'll reject one of those answers.
So the first one was -5 minus whatever was on the square root divided by the answer, or was the first
No,
one? The first was plus?
you tell me, read. Look at the board. You can see it in the formula.
Okay, so it was plus.
Okay, so it'll look like this as answers. Okay, the one that had the positive in the middle turned out to be negative. The one that had the negative in the middle turned out to be positive because the denominator was negative.
That's crazy.
So don't reject your answer till the last step. Now go like this. Okay, this is rejected because we're not looking for negative times. Now, what I want to do next is check these two answers with your graphing calculator, graphing part of it, like the actual graph. Okay, so we're going to go to Y1 now. So I'm going to pull the computer back up. But please keep these written down so at the end we can check that we get the right answers. And I'm going to show you a way that on your physics test, if you don't want to use the quadratic formula, you can use this method I'm going to show you. But I know in math class you're going to have to practice the quadratic formula, so you should know it anyhow. Okay? But I'm going to allow you to use this method. So, here's what we do. Press Y1, please. Or press Y. Go to Y1. Now, all you need to do is type in the equation that we started with. And if I go back to the original screen here, and I scroll all the way up, if I can find the original, there it is. At the top. Now, you're going to notice when you calculator, you can't put t squared, just use x. X is any variable on the calculator. So it's -4.9. Let me go back to my calculator. Alright, so -4.9. Where's the x? Above what key? Above x. Let me point it out. You know what? See that if you didn't know, look, it's right there. That's actually the x. It says x, t, theta, n. Those are all variables. This is just saying any independent variable. That's what that key always points to. Any independent variable. You don't put x there, but whatever variable is on the x-axis is what it's saying. That's not the same. Yeah, don't use alpha for this, please. Again, whenever you're plugging stuff into Y1, you need to use this x right here, please. Now,
And do you make it equal to 0?
no, hold on. Write it all out.
I did.
-4.9x squared plus 5x plus 2.7.
I have a question. Why couldn't you just have hit x squared on the calculator?
Because that's not the same thing.
Alright.
X squared just puts a square. That little squared symbol,
Oh, right.
it just has a square and put the key x there, right?
Solid. Alright, got it.
So that's what we should all have in Y1. Does everybody have that right now?
Yes.
Now, press Zoom 6 to standardize your graph. It always goes from -10 to 10 to -10 to 10.
I'm pretty sure I clicked X.
So at the top it's zoom. Okay, zoom. And then see the number 6? It says Z standard.
Here we go.
If you hit 6, it automatically formats your window so that you go from -10 to 10 and -10 to 10. Now, how many x-intercepts do you see?
Why did I get 2?
1, 2.
I see 2. Okay, I see an x-intercept I can't reach it?
You went to
I see an x-intercept.
1.41 and -39. Those are two answers.
Let me
Okay,
move this
Mr.
down.
Howell?
I see an x-intercept here and here.
Because I don't know how you guys have graphed this. I can do this.
Zoom 6. Zoom 6. That means
Yeah.
you have something up going on, you have something else you got to calculate. Clear all the stuff. Turn clouds off. If other people borrow it and stuff, it might have something in there. Give me a minute, I'll take a look at yours. Just follow along for me. So we got these two x-intercepts. These x-intercepts here are the two answers that we got a moment ago. But the question is, how do you figure them out? So let me show you.
Oh, yeah.
Okay? Here's how you do it. Press second, then press this trace button, because above trace you see calculate. See that word calc right there?
Yeah.
So press second, hit trace. It should bring up this command, or this list of commands. Now, in math, we call these things roots, or zeros of a function. So we need to press the number 2 now. Press the number 2, please. Okay, press the number 2. And what it's going to say is this. It's going to say left bound, question mark. Let me explain this, because other teachers explain it and you use the arrow keys. You don't need to use the arrow keys here at all. Let me explain it very clearly. Here's what left bound means. It means pick a number to the left of one of the x-intercepts. Okay, and when it says right bound, pick a number to the right. And what you're doing is you're building like a search domain. So if I were to show you graphically, let me show you on the board. Here, let's say the graph looked like this. Okay, hypothetically, I'm moving it over. And I wanted to figure out what that x-intercept was. Let's say that this was 1, this was 2, this was 3, 4, okay? So it's more obvious. If you put a left bound of 1 in, and then you pick for the right bound 2, it'll search for a root between those walls. So you're literally building like a barrier for it to search on the calculator. Now, if you accidentally do this, say for the left bound you pick 1, which is great, but then for the right bound you pick like 8, how is it going to know which one to pick? It won't. So you won't get the answer you want. You just keep getting the same one over and over again. So when you put up your walls, they need to be around the one root that you're specifically looking for. So in this case, I know, I can zoom in to see it, but I know that that root on the left is between -1 and 0. Again, I'll point that out so you can see it a little more clearly. Okay, this is -1 right here. This is the 0 right here, and there's a root in between. So for our left bound, I'm going to type in negative, not minus, but negative right down here. Make sure you hit the negative key, -1, and then hit enter. Then it says what? It says right bound, meaning pick a right wall now. So now we're going to put 0 in. So this search is between -1 and 0. It will search right in here, in that narrow passage. So let's put 0 in now for the right bound. Then it says guess. Now, if you did what I told you to do correctly, you don't ever have to guess. Just hit enter again. Okay, you don't have to guess if you do this the right way. Okay, and what you'll notice is you get a root of -0.39, which was, if we go back and take a look at the bottom left, there it is, -0.39. That's the one root. Okay, that's the one that we rejected. So we want to get the other one now. Let's practice this together again. When we're here now, what we have to do is the same commands. Press second, calculate, okay, which is second trace really. Okay, second trace. Then press the number 2. Now, in this case, I want to put up a wall to the left of this, and then a wall to the right of it. I'm probably going to choose 1 for the left wall and 2 for the right wall, because it's between the numbers 1 and 2. Okay, again, 1 is right here, 2 is right here, and my root is right in between. So for left bound, choose 1.
How do you choose?
Just press the number 1, type the number 1 in.
Okay.
Hit enter. For the right bound, press 2, enter. Now you don't have to guess, just hit enter again, and there's the other root. 1.41, the other answer we got. I'm glad you're happy. Because it's done with the calculator. The calculator wants to search for an x-intercept, but because you have 2 of them, he wouldn't know which one to pick. By giving it a left and a right like a wall, it says search between them. That's all it's doing.
You just put a number that like ranges.
Exactly. So if you know where approximately the root is or the x-intercept is, you pick something just to the left, something just to the right. But if I pick like -5 and +5, not going to know which one of those roots to pick because they're both in between it. So you need to put those walls like right next to the root you're looking for. Okay? Again, folks, this is why I'm encouraging you, bring your calculators to class. Okay, you need to practice this. You need to actually be able to do it. Okay, so, what do you prefer, honestly? I prefer the calculator method than this. This is a lot of room for error with the quadratic formula.
I'm a fan of
So if you want to use the calculator and just go ahead and find the roots like this, that's more than fine. Okay, it's up to you to decide. There's no work for that part. That's okay though. Because you're going to show all the work for the problem, and then you're going to get a quadratic at the very end, you're going to solve for time. If you use the calculator and just get the two roots, it's fine with it. Okay? Let's practice another one. We'll do trade next class. I think we're going to run out of time.
Yeah,
if we
it
start
ends at
trading.
37, got like 8 minutes.
Let's do a practice example together. And make sure you rearrange the equation so it's in the right order. Take a look. Ellie, can you close that door? Thanks, man. So, take a look. We've got 2t minus 5.7t squared equals negative 8.1. This is what's going to happen in the physics problem. You're going to get an equation like this, but you need to put it in the correct order, and you need to move everything over to one side. So, start by putting in the right order and move that 8.1 over so it's on the right side, or on the correct side. So, Kian, what do you got for me? Go ahead. Ask a question. Yep. So, tell me how to move it over to do that. So what do you have? Equals. All right, so Kian did the first step, right? He did the first step where we moved everything over. What's the second step, Manor? I thought that's what you were about to ask. What's the second step, Summer?
You have to label them, so the middle number is actually 8.
So this is A. Very good. This is A this time. This is B, and this is C. So if you want to just rearrange it and put it in order, you can write it that way so it's more obvious. Just rearrange it. As long as you carry the signs with stuff, you're fine. You can always do that. So switch the 2, but make sure the negative 5.7 gets carried over with the negative, and the 2t is positive. At this point in time, now you have your quadratic in standard form. This is A, this is B, this is C. Practice with the quadratic formula once, please, and practice with graphing. Verify that you get the same answer for both, please. Okay, you can work with the person next to you if you forgot your calculator, but please do it. I don't want you to have to do this. I want you to practice on your calculator. Look at that. Either write me a note at the top of theirs or just take all points and then bring it. Alpha stuff is the same. Alpha stuff is preceding numbers. I'm going to put up a homework over the weekend with like 4 problems. All you got to do is come up with the roots. Okay, the same thing we did just now. Quadratic formula and graphic. Hey, don't forget, the homework 2-3 was due today, so you didn't submit that.
I thought it was due yesterday.
Or was it yesterday? Sorry.
Subsection committed to today.
No, it was due yesterday.
Subsection said it was due today. You're lying, I can tell you're lying. I feel like you're lying.
Freshman office algebra 2.
What does that have to do with this?
No, yeah, no.
They had section 2-3 due today because their test was today. You guys was yesterday. Look on Moodle if you don't believe me.
Well, I didn't turn in my paper in the middle of class. I turned in before. It says turn in. There was a notification that said turn in. It's like only two. If you told me about. But I didn't do it in the middle of class. I did it before. It's like.
Okay, but it's still 1 day late. Yeah. Okay. Thank you, Kim. Ready, James? All right. Hey, Ken, is anybody in here next period? What does it say on day 3? Right there. Right there. Day 3, period 6. It's free. So just grab a seat. Calculator, pencil. two of these. So just write them in, that's the work you don't want to do. Okay, besides that, it's pretty straightforward. Beginning's all multiple choice, you don't need to show any work at all. The middle section is mainly conceptual. So from here on, short answer. These four you're going to answer with words only. And these ones. Here's going to be all mathematical. Here's mathematical. You guys need this period?
Yeah.
Are you sure? Day 3, period 6, I don't think we're here. Okay? Does that make sense? If you have questions, I'm going to be in here for a little